so this is the last paper 1 question that we've got. It's a trig 1. Don't forget that whenever you see any kind of circular function in real life, so obviously this is a Ferris wheel, it will be a trig function. So we need to write down the height. Oh, sorry, let's read the question first. So P is a point on the wheel. The wheel starts P at lowest point and that rotates at constant rate in an anti-clockwise direction. 1 revolution takes 20 minutes. So after 10 minutes, how high is it going to be above the ground? Well, after 10 minutes, it's going to be half a revolution. So hopefully you notice that that's going to be 100 meters. It's the same as the diameter of the circle. After 15 minutes, it would be at this position here because it's 3/4 of its way through. Again, hoping that should be clear that that would be 50 meters above the ground because it's at the radius. Here we've got some information about the height of it after certain time frames. Show that H8 is equal to 90.5. Well, we know the first 5 minutes, so they've told us the information between this point and this point. We know that circular functions have symmetry, so as this has increased to this point, it's then going to decrease to in the same manner going back up to this point. So if we were to look at minute, or when time was 6, it would actually be 100 meters minus this value here, so 34.5. At 7, it would be 100 minus 20.6. 8 would be 100 minus 9.5. 9 would be 100 minus 2.4. And at 10 minutes, we already know that it is at 100. So show that H8 is 90.5. So we would say that H8 is equal to 100 minus H2, or something of that nature, which is 90.5. That should be sufficient explanation there. Find H21. Well, 21 indicates that it's gone through 1 full cycle plus another 1 minute. Sorry, I forgot what the units were. Which means it must be at this point here, so it must be at 2.4. Oh dear. So 2.4 meters. H21 is equal to H1. Sketch the graph. Okay, it's a non-calc paper, so we have to think about this. We know it's a circular function, and it starts at 0. So our main points in this case are going to be the peak of it, so it's going to be at 10 minutes, 20, 30, 40. So we know at 10 minutes it's at its peak of 100 meters. At 20 meters it's back down to 0. At 30 it's back up about 100, and 40 it's back down here. So okay, so that's time on the bottom and height in meters. Hopefully you can see it's a sine or cos graph. Now they've indicated that it's a cos graph. We know that cos graphs normally start up at the value of 1, but this one's starting at 0, so that indicates that the value of A is obviously going to be negative. how negative is it? Well, the value of A is given by the amplitude, which we can see in this case is 100. I apologize, the full height is 100, the amplitude is therefore 50, so it's going to be negative 50. So that's where A comes from. We've then got to find B. So B is determined by the period of the graph. As you can see, the period of the graph is 20 minutes. So normally it would be 2 pi, but we divide that by 20, so we get the value of B as being pi over 10. And C indicates if there's been any vertical shift. So as we can see, normally our central line is at 0, but this one is at 50, so C would be 50. Sorry, so that was A is negative 50, B is pi over 10, and C is 50. So our full equation would be HT equals negative 50 cos pi over 10 t plus